Welcome to Module 3, Improving the Quality of Data. Data quality is a key component of any organisation's success, especially in our data-driven world. High quality data can drive better customer experiences, increasing retention and drive revenue. Poor data quality leads to analytics and insights that don't accurately reflect customers, misaligns moments of engagement, and creates negative brand experiences. The consequences of these effects can lead to loss of revenue and brand challenges in an increasingly competitive world. According to Professor Tom Redmond's recent study, only 3% of business data meets data quality standards. In this module, we will focus on how to identify, manage, and fix data quality issues. In this section, we will cover some techniques that can be used to help identify and reduce data quality errors. The following methodology has been derived from the concepts of Total Data Quality Management, or TDQM. The approach to managing data quality issues is relatively straightforward, and there are 4 process steps as follows. 1. Assess. 2. Analyze. 3. Improve. And 4. Review. We will take a closer look at these over the next couple of slides. The first step is to determine what the level of data quality actually is. Data quality audits are commonly used as an initial assessment tool to identify actual and potential data quality problems. The audit should focus on data use as follows. What data are we interested in? What is the metadata? How is the data used today? Who uses it? For what purposes is the data used? How often is the data used? What are the known problems with data quality? And what information systems does the data come from? The outcome from this phase is to better understand data quality and highlight areas that might need a more detailed assessment. The results of the assessment phase will also help prioritize data remediation efforts. As you identify problems, record them in a data issue register. We'll show you how on the next slide. To keep a track of data quality issues, create a data issue register. This register is the place where you can track data issues and report on remediation efforts, while simultaneously serving as a corporate memory for data issues. The register should contain the following information at a minimum: the problem date, the date when the problem was first identified or reported, the description, an initial description of what is known about the problem, the owner. All problems should have a responsible business owner assigned. The owner is responsible for coordinating remediation efforts. Status. Useful to monitor and report on progress. Suggested values are new, assigned, in progress, deferred, closed, and cancelled. Priority. Use priority to help determine the order in which issues should be addressed. Suggested values are low, medium, and high. Category. Use categories to group related issues. Resolution. Document the steps towards resolution in this field. Include the date for each update and by whom. Resolution date. Record the date the issue was resolved in this field. If you have any supporting evidence, such as report outputs, screen captures, and emails, be sure to attach these to the problem to create a comprehensive history of the problem. So if we take all those components for the data issue register and put them into a spreadsheet form, it might look something like this. The second step in the process involves taking a closer look at the data, the processes that created it, how it is created, how it is managed, and identify any opportunities for staff training. Data profiling is a technique that can be used in this step, and we cover this on the next slide. You should record your findings against the issue in your data issues register. Data profiling is a systematic and objective approach to finding and measuring the degree of data quality. Data profiling involves examining data attributes that form a record and then assessing the record as a whole. While there are numerous tests that can be applied to data, we will focus on a common set. The other point worth noting is there is no specific sequence for doing these tests, and not all may be relevant to all attributes. This section will explain the basics of each data profiling test, and there will be a tutorial at the end of this course if you'd like to learn more. If you are familiar with spreadsheet software, such as Microsoft Excel, then you can perform these tests easily there. As you go through and process each column of data, use color coding to highlight what you find. Any color will do, but choose a different one for each type of error you find. This will help greatly in allowing you to visualize the state of data overall and help you keep track of which data has been validated. Data profiling can be a lengthy exercise and can be divided up among multiple people to help speed up the process. There are data quality tools that can help, spreadsheets one kind, but there are others specifically built for validating data, particularly if you have large volumes of data. A bit of a tip, start small. Begin with a small subset of data. Even 10 rows may be a good start. As you learn more about your data, increase the dataset size and apply what you have learned. To begin with, let's look at missing values. My first comment about missing values is, it can be perfectly okay to have missing values, assuming the column definition states that values are optional. So before applying this test, check the metadata. It's worth counting the number of missing values anyway, because this can be used to determine overall record completion. Incorrect values. Might sound a bit obvious, but to identify incorrect values, you need to know what the acceptable values are, and these should be documented in the metadata for each attribute. Incorrect values range from incorrect type, e.g. a numeric attribute containing non-numeric values, values outside the acceptable range, e.g. the attribute expects 1, 2 or 3, and there are values outside this range, and invalid values, e.g. values that don't make any sense, such as a date of birth in the future. Duplicate values. Again, duplicate values may be acceptable so long as the attribute definition does not require unique values. This should be documented in the metadata, i.e. column is unique, non-unique. Regardless, it is worthwhile counting the number of duplicate values anyway, because these also can be used to determine overall record completion. Inconsistent values. This test requires a detailed look at all the values in a column to identify patterns of data that are not consistent. For example, if you had a column of numerical values, you can perform a statistical analysis to determine if the values cluster around the average and highlight any outliers. These are values that fall away from the average. Investigating the outliers may highlight a data problem. Format inconsistency. To perform this test, you must have a well-defined format for the attributes in your metadata. Assuming your attribute has a well-defined format, then you can apply a filter using a spreadsheet software or regular expression for more advanced searching, and identify values that don't match the defined format. The last test is domain validation. This final check compares values across related attributes. For example, if you have a column containing the states of Australia and another column containing the towns in each state, then you might have a business rule that says town names must only exist in one state. Step 3 in the process is improve. Once you have completed your assessment, consider what actions need to happen. Fixing the incorrect data is one aspect, but if you don't remedy the underlying problem, i.e. the root cause, then the issues will continue. What actions you take will largely depend on what you find. For example, missing or inaccurate data may highlight a problem with data entry or collection, including the way the information system captures the data. Ultimately, the longer the delay between discovering data quality issues and fixing them, the harder and more costly it is to fix. The most cost-effective approach is to fix the data in the source system. Finding data quality problems is the challenge. Knowing what and how to remedy these issues is the second part of the challenge. In the next part of this module, we will look at a process called data quality by design that can help with this. Remember to include your resolution plans and outcomes in your data issue register. The final step in the process is review. After the changes have been made, you will need to revisit and check on the specific areas that were changed in order to see if those changes have been effective. You can use this same 4-step process to achieve that outcome. The review process may need to occur over a period of time in order to see if the change was effective. For example, if the change involved training staff, then it may take a few weeks or months before you see an improvement. Your data issue register can assist with the review process by allowing you to track which issues have been investigated while being able to report on current state. As we have seen from the process above, addressing poor quality data involves more than just fixing data. It involves undertaking a detailed analysis to determine the underlying cause of data quality problems in order to determine the most appropriate way of preventing these from reoccurring. The process above needs to be scheduled as part of continual improvement activities, and it needs to be allowed the time necessary for the job to be completed properly.